Okay, so we're going to continue to add some stuff to our player controller here. We want to make sure we're still in the script. I'm going to zoom in a little bit to make it just a touch easier for you guys to see. There we go. So what we need to do is add a couple more of these methods that are going to do some stuff to actually move our player around. So what we want to start with is clicking outside of our void update next to this bottom bracket. We're going to hit enter a few times to give us a whole bunch of space. And we're going to start by typing void process input, open and close parentheses, and then we want to have an open and close curly bracket. We're going to hit enter, and that's going to give us some space inside here. We're going to start with typing movedir, that vector3 we declared earlier. We're going to say movedir.z is equal to input.getAxis. And we need open and close parentheses after that, and quotation marks inside the parentheses. And inside those quotation marks, we're going to say vertical. And add our semicolon on the outside. That's going to set the z value of that vector3 to the vertical input axis, which is 1 if you're holding W, or -1 if you're holding S. Next, we're going to say movedir.x is equal to input.getAxis. And parentheses and quotation marks, this one is going to be horizontal. And add our semicolon. Next, we're going to say if movedir.magnitude is greater than 0, what we want to do is say movedir is equal to transform.transform direction movedir. And the reason for this is our move direction is always going to be like 1 or -1, and we want to actually align it with the way our player is facing. So by doing this, this line here, we're going to make it so that 1 or -1 is shifted to account for the rotation of our player. After that, we're going to hit the enter key, type else, and we're going to say movedir equals vector3.0, and add our semicolon at the end. And once we've got all that, we've got our process input method done. We're now going to go back up into our update method. We're going to click inside the brackets, and we're going to type process input, open and close parentheses, and then semicolon. And what that's going to do is call this process input method once per frame. And one frame, or a frame, is called as fast as your computer can call them. So the faster your computer, the more you're gonna call process input. But we want to make sure that we're doing that every time we can. And a frame is when the what you see on screen is updated. It happens like 140 times per second. It can happen more or less depending, again, on the speed of your computer. But we want to make sure we're checking input on every single possible frame that the player could be pressing a button. Next, what we'll want to do is click on the outside edge of this update bracket, hit enter a couple times to give some space, and we're going to say private void fixed update. And if you have IntelliSense hooked up, you'll see it turn blue and all that, but we want to make sure we match this directly here. And we're going to do some math to our rigid body. So we're going to say current velocity, that vector3 we had earlier. We're going to set that equal to rigid.velocity. And that's the velocity of our player moving in the world. We're going to say current velocity.z equals movedir.z times 10. And that's because we want to increase the speed a little bit here. We're also going to say current velocity.x equals to movedir.x times 10. And again, to increase the speed a little bit. Next, we're going to do some manipulations to the rigid body. So we're going to say rigid.angular velocity. This is the velocity that handles turning our player, and we're going to set this to 0 because we want to make sure our player isn't turning. It's on a capsule, so it's got a rounded bottom. We want to make sure we avoid it turning on its own. We're going to say rigid.inertia tensor rotation, which is going to be a little bit easier to spell if you have IntelliSense, so feel free to take your time to copy that down if you don't. We're going to say that equals to quaternion.euler vector3.0, and that's again going to help us prevent spinning. And I know these are huge words and they're hard to spell, so again, take your time, make sure you get those copied correctly, because any missing capitalization or misspelled words are going to cause errors. And then finally, we're going to say rigid.velocity is equal to current velocity. And add our semicolon at the end. And now our player should move. So if we switch back over to our our scene here. You're going to see our guy is hanging out here. We want to, again, make sure that player controller object is on our player controller. We can also take the time now to go into our canvas and grab this this health text option and put it in here. We're not using it yet, but we'll use it later, so we can put that there now. We haven't made our game over text, so when we make that later, we'll add that. But now with all this stuff here, we can go ahead and hit play. And here we are, we're standing here. You'll notice you can't move your mouse and move anything, but if we press WASD, we should be moving. Although it looks like we're not for some reason, so let's explore that. Why is our player not moving? Oh, there he goes. Oh, it looks like it's just the camera's not moving. Oh, okay. I was a bit confused there, but it does look like it works. So we just need to make sure that we take our main camera here. We want to drag that into our player game object. And what we need to do is actually adjust our camera. We want it to be inside our capsule's head. So we're going to hit 0, 0, and 0 after we have it inside our player game object here. We're also going to lift it up a bit because we want it to be about where your head would be. Now we'll see if we go into here. Oops, let me get rid of that. If we go into here and hit play and move around, now we'll see it actually moves along. So yeah, easy thing to overlook, but yeah, we want to make sure our camera is inside our player and our player is not stuck on the ground, and our constraints are set to rotation and not freeze position.